Okay, we're on page 47 now. So just to be clear, you guys just finished with page 44. We are not doing page 45. We are not doing page 46. We're flipping here now to the set so we can practice the efficient methods. And the other thing I wanted to make sure is that you realize that this space they gave us is pretty small, and you may need to have some separate paper, some blank paper available in order to complete some of these using your preferred method. So please get out a piece of paper that you can use, like in your math notebooks would be perfect for when we get to these methods in case you need it. So taking a peek at number 1, I'm telling you right now, you guys, if our choices, here's our choices. Making a table of values, pretty much I'm probably never going to use this. I'm just kidding. Graphing it, probably not going to use it. 3 is going to be my first choice I really go to, the factoring method. 4 is going to be try and complete the square to solve. And then no matter what, we always have the option of going to the formula. So could you do this entire section just straight up using the formula? Yes, you could. You do you, okay? So the first one, if I test it out, actually, let me make this way smaller. I don't want to go to new paper yet. If I test it out, what times what equals 60 and adds up to 17? How about 12 and 5? And so since my factors, x plus 12, x plus 5, work for this, I can then solve each one. And I get my 2 real roots. Okay, let's check the next one. Same concept. Does factoring work? What times what makes 39 and adds up to 16? Well, 3 times 13 makes 39. So I can solve each piece. I get -3 and -13. There's my 2 real roots. Okay. Now for this next one, notice that what 1 times 5 does not add up to 7. So immediately we're thrown into a choice here of needing to pick a different method. So if it's not factorable, can't do this guy. I look next to completing the square, but 7 divided by 2, my B work is already going to yield a fraction. So I'm like, ew, I don't want to do that one either. And I'm just going to go for the straight up formula on this one. So I'm going to go get A, B, and C and try plugging in. Now let's see how we're doing on space issues here. -7 plus or minus 7 squared minus 4 times 1 times -5, all over 2 times 1. -7 plus or minus square root of 49 plus 20 over 2 is going to give me -7 plus or minus square root of 69 over 2. Now, I go off to the side and see if root 69 can break down into any perfect squares. So I can tell that 3 goes in, right? 3 times 23. Well, 23 is a prime number and 3 is a prime number, so I can't break this down anymore. So actually, root 69 is already done. And so this answer, -7 plus or minus root 69 over 2, it's done. I don't have to go any further. Those are my 2 real roots. So the formula in this case was kind of easier because I did not have to simplify a lot on this one. So that was nice. Okay, looking at the next one, I'm going to try factoring. What times what equals -15 and adds up to 14? 1 times 15, -1. So I get 2 factors of negative 1 and 15, the first factor, 3x minus 1, is already simplified. The second factor of 3x plus 15, I can divide a 3 out of both sides to get x plus 5. So my two factors are 3x minus 1 and x plus 5. Remember that if you don't prefer the XT method, you could do the backwards box, you can do the guess and check method. You have a couple options there. So solving this one, 3x minus 1, opposite of the back, positive 1, divided by the front. I'm going to get 1/3 when I do that full work. And solving this one gives me -5. So again, my preferred method here of factoring would be my first choice. Because there's a 14 in the middle, divided by 3, I would not choose complete the square, but I could have done formula on this one if I wasn't sure that it was factorable, and it would have totally given me the same two answers. For this next one, I need the 8 on the other side before I can assess the situation here. Now that it's equal to 0, I take a peek. What times what makes 8 and adds up to 12? This is not factorable. So I have to choose my method. This one I could complete the square on pretty easily. So actually I'm going to rewrite it with the 0 equals. Let me use a different color here since it's so close to the other purple work. And I'm going to move that plus 8 over. Why is it a plus 8? Because remember, I wanted it on the other side together with all the others. Okay, so step 1B work is going to be -12 divided by 2, which is -6 squared, which is 36. So I'm going to be adding 36 and subtracting 36 to balance. That makes the x minus 6 squared factors. And then 36 plus 8, -36 plus 8 gives us -28. In order to solve this, I'm going to have to add 28 to both sides. That leaves me 28 is equal to x minus 6 squared. I then square root both sides to get plus or minus root 28 is equal to x minus 6. I add 6 to both sides, and I need to simplify that radical. Root 28 could be 7 times 4, or 7 times 2 times 2. So a 2 comes out, a root 7 stays under, and there we go. Why do I not get a whole number answer? Because this one was not factorable, so there's definitely going to be a square root in my answer. 6 plus or minus 2 root 7, final answer. You could have flipped it around to put the x equals in front as well if that felt better. Do you see what I mean about the extra paper and how you might not want to squish all this in there? All right, last one. What do you think? I hope you can pause the video and try this one on your own and then see how you did. Okay. Well, I need it to be equal to 0 first, so let's minus the 7. And then let's go check and see if it's factorable. -7 and 6. Couldn't that just be 7 times 1? And I would make it a -7. Oh, I don't know why my screen just turned black, you guys. That's kind of cool. And so then we get x minus 1 times x plus 7. Those are my two factors. So solving the first factor, we get x equals +1. Solving the second factor, we get -7. So this one's kind of nice because it worked out to be factorable and to whole numbers. Sorry, you guys, I'm going to try to open this up again and see if that black screen goes away. Hang on. Okay, in the next section, while this is pulling back up, it asks you when you would use the specific methods and when it's more efficient to use one versus the other. And so this is going to be in your own words. I'm going to give you some ideas of what I would write, but then you're going to write this in your own words for the next section. Okay, so for example, summarize the process for solving a quadratic by the indicated strategy. Give examples with written explanation and when it's best to use this strategy. So for completing the square, I would use this when it is not factorable and when the b is even. I did not like when the b was odd and it made a terrible fraction that we would have to work with. And then you're going to write out the steps for completing the square. So for example, we're all very familiar with the steps. Step 1, make space. Step 2, the b work. Step 3, add and subtract. Step 4, get the factors. But after that, that's how to get it to vertex form. After that is when we have to add the number to the other side and root both sides. So there's some additional steps. So go ahead and write out those steps for yourself here in your own words. The factoring method is the preferred method to always try first, but if it is not factorable, we have to try another strategy. Right? Go ahead and write out your steps for factoring in your own words. Finally, the formula. This one always works. I always have some students every year who use this every time. They literally don't do factoring, don't do complete the square. They know the formula always works. I would use this on a quadratic that is not factorable and has an odd b. Okay. All right. Last but not least, they're having us do just this one last problem here for all of our usual steps to get the x-intercepts, to get the y-intercept, to get the vertex, to get the line of symmetry. They won't let this go. It's going to be on the next test again. So getting the y-intercept, remember, is when x is 0. Plug in a 0 for me. And we would just get that f of 0 is equal to 0 plus 0 plus 13. So going up to count 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 on here, so I have to count by twos. 2, 4, 6, 8, 10, 12, 14. So my y-intercept is going to be in the middle there. All right, to get my x-intercepts, for this one, it's not factorable. So I'm going to go off to the side and do complete the square work. So we're going to say 0 is equal to x squared plus 8x, make space. Off to the side, b work. Makes 4 squared, makes 16. Add 16 and subtract 16. We get the x plus 4 squared perfect minus 3. Now, because I just put this into this form, I can actually see right now what my vertex is. My vertex is -4, -3. Do you see how I'm using this other work? Remember how the sign is the opposite of the +4? So -4, -3 is going to be somewhere like right there. All right, for my x-intercepts, I keep going. I add 3 to both sides. I square root both sides, and I get √3 equals x plus 4 minus 4 to both sides gives me -4 plus or minus √3. Okay, so √3 is something less than √4. So it's kind of like saying -4 plus something less than 2. So we've got to, like, you could grab a calculator and plug this in and see the exact value. But we know we're going to go in a direction of root 3 in this direction and negative root 3 in this direction from this line of symmetry through the vertex. We're going to plus root 3 in that direction and a minus root 3 in this direction. And it's not a full 2 because root 4 is 2. So my x-intercepts are negative 4 plus or minus root 3. My line of symmetry goes straight down the negative 4. All right, connect that graph. Oops. I hope you do way better than me at that. All right, something like that. How'd you do?